In section 2, we're going to go over solving quadratic equations. So this should be a refresher from last year in Algebra 2. So remember that a quadratic equation is any quadratic of the form ax squared plus bx plus c equals 0. Okay. So we have learned several ways to solve quadratics, which is what we're going to be reviewing in this section to prepare us for solving more advanced equations in later sections. So let's briefly go over how to solve by factoring. So given you have a quadratic in that standard form, to solve by factoring, you find values of a times c that sum to b. And you're going to get something of the form x minus p times x minus q equals 0. And then p and q are going to be the solutions to the quadratic. So let's do a couple examples where we solve by factoring. So we have 9x squared equals 5x. That is not in the form. So remember, you want ax squared plus bx plus c equals 0. So the first thing we need to do is get it in that form. So we're going to subtract 5x from both sides. So we're going to get 9x squared minus 5x equals 0. Now this isn't a typical solve by factoring. What we're going to instead do is factor out the GCF. So I look, both of my terms have an x in common. So if I factor out the x, we're going to get 9x minus 5 left in parentheses equals 0. I take each term and set it equal to 0 and solve. So we get x equals 0, and then we get 9x minus 5 equals 0. Well, x equals 0 is already solved. That is one of our solutions. Now we just need to solve the 9x minus 5 equals 0. So we're going to add 5 to both sides. So we get 9x equals 5, divide by 9, and we get x equals 5/9 as our second solution. Next, we want to look at x squared minus 7x minus 8 equals 0. So we want to find values that multiply to negative 8, but add to negative 7. There are multiple ways to get negative 8 when you multiply. The only way to get them to add to negative 7 is if you have negative 8 and positive 1. Negative 8 times 1 is negative 8. Negative 8 plus 1 is negative 7. So we have x minus 8 times x plus 1 equals 0. Take each factor, set it equal to 0, and then solve. So add 8. We get x equals 8 as one of our solutions, and then subtract 1, and we get x equals negative 1 as our second solution. So the last example we're going to look at is 3x squared minus 5x minus 2 equals 0. And there's a couple different ways you can factor when the leading coefficient is a value other than 1. I'm going to show you just one of those methods. So remember, we want to find the factors of a times c that sum to b. So first I have to figure out what a times c is. So a is the 3, c is the negative 2, so we're going to get negative 6, b is the negative 5. So I want to find the values that multiply to negative 6 and add to negative 5. It's going to be negative 6 and positive 1. And now because my leading coefficient is a value other than 1, I'm going to divide both of these terms by that leading coefficient and then simplify. Negative 6 divided by 3 becomes negative 2. 1 over 3 doesn't simplify. So the way I write this in factored form is the value in the denominator gets put in front of x. So negative 2 over 1 would be 1x, and then the value in the numerator gets put after that, so negative 2 minus 2 in one set of parentheses. My second parentheses, denominator goes in front of x, so we get 3x, and then the value in the numerator goes afterwards, plus 1 equals 0. set each factor equal to 0. So x minus 2 equals 0, 3x plus 1 equals 0, and solve. So add 2. We get x equals 2 as one of our solutions. Second equation, subtract 1. We get 3x equals negative 1. Then divide by 3. And we get x equals negative 1/3 as our second solution. You do not have to use this method to factor when the leading coefficient is a value other than 1. If you prefer to use the box method or another method you may have learned previously, you are more than welcome to use that instead of the method that I just did. Let's take a look at a method called the solving by the square root property. So when we solve by the square root property, the first thing we want to do is isolate the term that contains the squared variable. Then you're going to take the square root of both sides and solve. And you should always end up with two solutions when you use the square root property. So if we go ahead and take a look at our first example, x squared minus 8 equals 0. So first we want to isolate our squared variable. So that means we're going to add 8 to both sides. So we get x squared equals 8. Next we're going to take the square root of both sides. Square root of x squared becomes x. Now, because I'm taking the square root of a number, technically you're going to get a positive or a negative value, since positive square root of 8 squared is 8 and negative square root of 8 squared is 8. Now, I can't actually take the square root of 8. It does give a decimal, but I do want to simplify the square root of 8. So if you remember how to simplify square roots, you break it down by finding its factors. So I'm going to take 8, I can break it down as 4 times 2, break down 4 as 2 times 2. And then I can pull out any pairs of numbers, and there's one pair of 2's. So we're going to get x equals plus or minus 2, and then underneath the square root we put any numbers left over, which is this single 2. And that's going to be my solution. Next we have x minus 1 squared equals 5. Well, I can't really isolate my squared term anymore since x minus 1 is all being squared. So my first step is actually going to be to take the square root of both sides. So we get x minus 1 equals plus or minus, and you can't simplify the square root of 5, so it's going to stay square root of 5. And then my last step is to solve, because I don't have x by itself yet. So we're going to add 1 to both sides. So we get x equals, and I can't add the square root of 5 and 1 since 1 is not underneath the square root. So we're going to write it as 1 plus or minus the square root of 5. Typically we're going to put a number in front of the plus or minus sign. You can write it after as plus or minus the square root of 5 plus 1, but it doesn't, it's not the typical way we write the solution. So x equals 1 plus or minus the square root of 5 is our final answer. Next, we're going to review how to solve by completing the square. So when we solve by completing the square, the most important thing is that the leading coefficient is 1. So instead of a quadratic of the form ax squared plus bx plus c equals 0, we're looking at something of the form x squared plus bx plus c equals 1. So a must be 1. If it's not, you're going to want to divide through by a. So as long as a is 1, your first step is going to be to move c to the other side. So it's just x squared plus bx equals c. Then you're going to find the value that makes x squared plus bx a perfect square. And we're going to add it to both sides. By adding this value to both sides of the quadratic, we're not actually changing the original equation. Next, we're going to factor the left side. And the last step, step 4, is going to be to solve for x. And we are going to be using that square root property that we just talked about to help us solve for x. So let's go ahead and look at our examples. So we have x squared plus 4x plus 10 equals 0. And a is 1, so we can go ahead. We don't have to worry about dividing by anything. First step is going to be to move c to the other side. So that's going to be subtracting 10. So you have x squared plus 4x. And I'm going to leave that room for that constant equals negative 10. Now, in order to find that value that makes x squared plus bx a perfect square, we're going to take b, which is 4, we're going to divide it by 2, and we're going to square it. That value is going to give us a perfect square trinomial on the left side. So 4 divided by 2 is 2, 2 squared is 4, so we are going to add 4 to both sides. Now we want to factor the left side, x squared plus 4x plus 4. So the value that multiplies to 4 and adds to 4 is 2. So we get x plus 2 times x plus 2 equals negative 6. And another way to write x plus 2 times x plus 2 is x plus 2 squared. And it equals negative 6. So now we're going to do that last step, step 4, solve for x. And we're going to use the square root property. So we're going to take the square root of both sides, and we end up with x plus 2 equals plus or minus. Now we notice our right side, we're taking the square root of a negative number, which we can't do. So we know we're going to have an imaginary solution. So I'm going to write I square root of 6, since the square root of 6 cannot be simplified. Then I want to finish getting x by itself, so subtract 2 from both sides, and we get x equals negative 2 plus or minus I square root 6. And this is going to be our final solution. Next, we want to solve x squared plus 6x minus 9 equals 0. Again, a is 1, so we can go ahead and move c to the other side. So we're going to add 9. So we get x squared plus 6x plus, leave our space, equals 9. Take b, divide it by 2, and square it. 6 divided by 2 is 3. 3 squared is 9. So we're going to add 9 to both sides. Now I want to factor that left side. Well, the value that multiplies to 9 but adds to 6 is 3 and 3. So we're going to have x plus 3 squared equals 18. Take the square root of both sides. We get x plus 3 equals plus or minus. Now, unlike our previous example, 18 does simplify. I can write it as 9 times 2, and then 9 is 3 and 3. So this is going to be plus or minus 3 radical 2. Our last step is going to be to subtract 3. My final answer is x equals negative 3 plus or minus 3 square root 2. Typically, it's best to use the completing the square method if you can't factor the quadratic and the leading coefficient is 1. We never use the completing the square if a quadratic can be factored, because this is a lot of extra work that's not necessary if I can go ahead and factor the quadratic. The last method we're going to review is the quadratic formula. So remember, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And remember, in order to use the quadratic formula, your quadratic has to be in the form ax squared plus bx plus c equals 0. And then a, b, and c are taken and plugged into the formula. So if we look at our first example, we have x squared minus 3x plus 5 equals 0. And it's always a good idea to go ahead and identify a, b, and c first. So a equals 1, b equals -3, and c equals 5. So now we just plug it into the formula and simplify. So we get x equals negative b, so -3, plus or minus the square root of -3 squared minus 4 times 1 times 5 all over 2 times 1. So -3 is going to become a +3. So we have x equals 3 plus or minus the square root. Now when I square a negative number, it is positive. So we get 9 minus 4 times 1 times 5 is going to give us 20 all over 2. X equals 3 plus or minus the square root of -11 all over 2. So the square root of -11, I'm going to want to pull out the I to represent the negative. So we have 3 plus or minus I square root of 11 all over 2. And the square root of 11 doesn't simplify, so this is going to be our final answer. Next we have 3x squared minus x minus 1 equals 0. So we're going to have a equals 3, b equals -1, and c equals -1. So plugging in, we get x equals -1 plus or minus the square root of -1 squared minus 4 times 3 times -1 all over 2 times 3. So we get x equals 1 plus or minus the square root of 1, and then -4 times 3 times -1 is going to give us a +12 all over 6. Then we get x equals 1 plus or minus the square root of 13 all over 6. And this square root of 13 doesn't simplify, so this is going to be our final answer. Last example, we have x squared minus 3 equals 7x. And this quadratic is not in the correct form. So our first step is going to move the 7x. So we have x squared minus 7x minus 3 equals 0. Now we can identify a, b, and c. So a is 1, b is -7, and c is -3. So plugging into our formula, we get x equals -7 plus or minus the square root of -7 squared minus 4 times 1 times -3 all over 2 times 1. So x equals 7 plus or minus the square root of 49 plus 12 all over 2. So we get x equals 7 plus or minus the square root of 61 all over 2. And the square root of 61 does not simplify, so this is going to be our final answer. The nice thing about the quadratic formula is that you can use it on any quadratic. It doesn't matter if the leading coefficient is 1 or not, and it doesn't matter if the quadratic can be factored, because it will always give you the correct solution. So if you're ever struggling to solve by factoring or completing the square, you can always fall back on the quadratic formula to help you solve a quadratic equation.